So, what if I told you that a piece of ice, 800,000 years old, could tell us something profound about our planet's future? Well, today, that's exactly what we're going to do. We're going to decode the story that's been trapped in Earth's ancient atmosphere.
Okay, so we're always hearing about this, right? CO2 levels are on the rise. But here's the real question, the one that really matters. Is this just normal? Is this something the Earth just does from time to time? Or are we living through something totally different?
To figure that out, we have to know what normal even looks like for our planet's climate. So let's dig into the evidence and ask, is this current rise just part of a natural cycle?
I mean, let's get one thing straight. Earth's climate has never been a flat line. Not even close. It's always been changing, swinging back and forth between frigid ice ages and much warmer periods. So yeah, change itself is totally normal. That's our starting point.
But that leads to a fascinating problem, doesn't it? How on earth can we possibly know what the atmosphere was like, say, 500,000 years ago? It's not like we have a time machine. But it turns out scientists have found something that's the next best thing.
The answer has been waiting for us, locked away in the absolute coldest places on the planet. It's time to explore what's basically Earth's own frozen archive.
Okay, so picture a place like Antarctica. It's so unbelievably cold that the snow that falls just never melts. And every single year, a new layer of snow piles on top, squishing the layers underneath it. Over thousands and thousands of years, all that pressure turns the snow into these distinct layers of ice, creating this perfect year-by-year timeline of history.
But here's the really amazing part. The real secret is what's trapped inside that ice. As all that snow got compressed, it trapped tiny, microscopic bubbles of air. And those aren't just any air bubbles. They're perfect, pristine samples of the Earth's atmosphere from the exact moment that snow fell.
So we've got this incredible library of ancient air. But how do you, read it? Well, scientists have figured out a truly ingenious way to decode these tiny atmospheric time capsules.
To really get how this works, let's just do a quick thought experiment, one you could basically do in your own kitchen. Think about it. How would an ice cube made from regular tap water look different from an ice cube made with, bubbly seltzer water?
The idea is actually super simple. Anytime water freezes, it can trap little bubbles of gas. But carbonated water, right, it has all that extra CO2 pumped into it. So when you freeze it, it's going to trap way more of those CO2 bubbles, which is why it often looks kind of cloudy or white. It's a direct link. More CO2 in the environment means more CO2 gets trapped in the ice.
So scientists are basically doing the exact same thing, just on a much, much bigger and more precise scale. First, they drill deep, sometimes miles deep, to pull up these long cylinders of ice we call cores. Then by counting the layers, they can isolate ice from a specific time, say 300,000 years ago. They take that sample, melt it in a vacuum-sealed chamber so the ancient air gets released and captured. And finally, they use super-sensitive equipment to measure exactly how much CO2 was in that tiny bubble of air.
Okay, so after decades of this incredible work, drilling cores, analyzing hundreds of thousands of tiny air bubbles, what did we find out? This is it. This is the big reveal. Let's take a look at the 800,000-year record. And here it is. Just take a second to look at this graph. It represents a massive scientific achievement. This is a direct measurement of our atmosphere's CO2 going back 800,000 years. On the right side, that's today. And as you move to the left, you're literally going back in time.
And you can see it right away, can't you? There's this clear rhythm to it. For almost 1 million years, CO2 levels have cycled up and down, up and down. Those low points, the valleys on the graph, those were the major ice ages. And the high points, the peaks, those are the warmer periods in between, kind of like the one we've been in for the last 10,000 years or so.
But look a little closer at those peaks. For 800,000 years, notice how they never ever go above a certain line? The natural limit, the absolute ceiling for CO2 in the atmosphere, was about 300 parts per million, or ppm. For all that time, that's as high as it got.
And then you get to the very, very end of the graph, our time. In 2019, the average CO2 level hit almost 410 parts per million. It didn't just break through that old ceiling, it completely shattered it. We're in territory our planet has not seen for at least 800,000 years.
This huge contrast, well, it leads us to a pretty unavoidable conclusion. We're looking at a truly unprecedented spike.
And hey, you don't even have to take my word for it. The scientists who put all this data together, they wrote it right on the chart. The recent increases are rising faster and going higher than anything they found in the entire ice core record.
So let's go all the way back to the beginning, to our very first question. Is this normal? The ice core data gives us a really clear, black and white answer. That slow, rhythmic dance of ice ages and warm periods, that is the normal cycle. This sharp, almost vertical line on the far right of the graph, a jump that's happened in just the last 100 years or so, that's something else entirely. No, it is not normal.
So this whole 800,000-year story really forces us to ask one last, absolutely critical question. For almost 1 million years, our planet's climate played by a certain set of rules. But in the last century, those rules have been broken. So what's so different about today?